Okay, so today we're going to find the inverse of a 3 by 3 matrix. So here we have my matrix A, and it's 1, 4, 0, 2, 0, 2, 3, 2, 5. Now, to find the inverse of a 3 by 3 matrix, it's not so difficult. First, what I'm going to do is rewrite the first two columns of this. So we have 1, 2, 3, 4, 0, 2. Just going to put this in a separate, different color so that we can see what's going on. So what I'm going to do is take my blue highlighter and I'm going to circle on the diagonal. Always these 3 diagonals in that direction, and then using a different color, circle 3 in the opposite direction. So it's going to be the blues minus the pinks. So what we have here is 1, 0, 5, and it's going to be written as 1 multiplied by 0 multiplied by 5, plus 4 times 2 times 3, plus 0 times 2 times 2. And this is all going to be right. So then minus, put a big bracket, 3 times 0 times 0, plus 2 times 2 times 1, bracket, plus 5 times 2 times 4. So 1 times 0 times 5 is 0. 2 times 4 times 2 times 3, 24, and 0 times 2 times 2 is 0. Here we have 3 times 0 times 0, which is 0. 2 times 2 times 1, we have 4. And finally, we have 5 times 2 times 4, which is 40. So what we're left with is 24 minus 44, which gives us negative 20. So the determinant of A is equal to negative 20. And this will be used later. Okay, so I rewrote matrix A for reference. Now you probably see some numbers at the side here, you're wondering how I got them. So what I did, I wrote N for the new, and we're going to create a new matrix. And I have these strips of paper I'm going to use we're going to start with 1, which is the first number of the first row, first column. So we're going to cover this and that, and we're left with 2, 0, 2, 2, 5. And so we write it here, 0, 2, 2, 5. Now these mean that we're going to find the determinant of this. Then we come to 4, so we cover where the column where 4 is, and the row where 4 is, and we're left with 2, 2, 3, 5. See, we wrote 2, 2, 3, 5. I'm going to find the determinant of that. So then we come to 0. We cover the column and the row, and we're left with 2, 0, 3, 2. 2, 0, 3, 2. So now we're going to move on to the number 2, which is in the second row and still the first column. So we cover that up. We cover the column that it's in, and we're left with 4, 0, 2, 5. So you come here and we write 4, 0, 2, 5. So then we move on to 0. So we cover that row, that column, and we're left with 1, 0, 3, 5. So come here, 1, 0, 3, 5. Cover 2, cover the row that 2 is in, the column that 2 is in, and the row that 2 is in, and we're left with 1, 4, 3, 2. Again, we're going to find the determinant of that. And finally, we're at 3. So we cover that column that 3 is in, we cover that row, and we're left with 4, 0, 0, 2. Come here, 4, 0, 0, 2. Cover this, where the 2 is, cover that. Cover this row. We're left with 1, 0, 2, 2. We come here, 1, 0, 2, 2. And finally, 5, we cover that column, that row, and what we're left with is 1, 4, 2, 0. Come here, we write 1, 4, 2, 0. I'm going to put it in a big gigantic matrix box. My poor drawing, but so that we still know that this is in fact a matrix. So then we're going to find the determinant of each of these numbers, and I'm going to show you that shortly.